Self-driving car technology. A self-driving car is a vehicle that uses a combination of sensors, cameras, radar and artificial intelligence to travel between destinations without a human operator. To qualify as fully autonomous, a vehicle must be able to navigate, without human intervention, to a predetermined destination over roads that have not been adapted for its use. Companies developing or testing autonomous cars include Audi, BMW, Ford, Google, General Motors, Tesla, Volkswagen, and Volvo. Google's test involved a fleet of self-driving cars, including Toyota Prius and an Audi TT, navigating over 140,000 miles of California streets and highways. How self-driving cars work. AI technologies power self-driving car systems. Developers of self-driving cars use vast amounts of data from image recognition systems, along with machine learning and neural networks, to build systems that can drive autonomously. The neural networks identify patterns in the data, which is fed to the machine learning algorithms. That data includes images from cameras on self-driving cars, from which the neural network learns to identify traffic lights, trees, curbs, pedestrians, street signs, and other parts of any given driving environment. Cars with self-driving features. Hands-free steering centers the car, without the driver's hands on the wheel. The driver is still required to pay attention. Adaptive cruise control, down to a stop automatically, maintains a selectable distance between the driver's car and the car in front. Lane centering steering intervenes when the driver crosses lane markings by automatically nudging the vehicle toward the opposite lane marking. Levels of autonomy in self-driving cars. The U.S. National Highway Traffic Safety Administration lays out 6 levels of automation, beginning with Level 0, where humans do the driving, through driver assistance technologies, up to fully autonomous cars. Here are the 5 levels that follow Level 0 automation. Level 1, an advanced driver assistance system, aid the human driver with steering, braking or accelerating, though not simultaneously. An ADAS includes rear-view cameras, and features like a vibrating seat warning to alert drivers when they drift out of the traveling lane. Level 2, an ADAS that can steer, and either brake or accelerate simultaneously, while the driver remains fully aware behind the wheel, and continues to act as the driver. Level 3, an automated driving system can perform all driving tasks under certain circumstances, such as parking the car. In these circumstances, the human driver must be ready to retake control, and is still required to be the main driver of the vehicle. Level 4, an ADAS can perform all driving tasks, and monitor the driving environment in certain circumstances. In those circumstances, the ADAS is reliable enough that the human driver needn't pay attention. Level 5, the vehicle's ADAS acts as a virtual chauffeur, and does all the driving, in all circumstances. The human occupants are passengers, and are never expected to drive the vehicle. Self-driving car, safety, and challenges. Autonomous cars must learn to identify countless objects in the vehicle's path, from branches and litter to animals and people. Other challenges on the road are tunnels that interfere with the global positioning system, construction projects that cause lane changes, or complex decisions like where to stop to allow emergency vehicles to pass. The systems need to make instantaneous decisions on when to slow down, swerve, or continue acceleration normally. This is a continuing challenge for developers, and there are reports of self-driving cars hesitating and swerving unnecessarily when objects are detected in or near the roadways. Car makers are subject to Federal Motor Vehicle Safety Standards, FMVSS, and NHTSA. Reported that more work must be done for vehicles to meet those standards.